Greenhouse effect is an impact of atmospheric gases that absorb the heat radiated from the Earth's surface and thereby causing greenhouse effect. This process is intensified by human activities and has become a big cause of global warming and climate change. In this article, we are going to cover the types, sources, effects, and mitigation strategies of greenhouse gases. Greenhouse effect. The solar radiation enters Earth in the form of short waves and easily passes through without much absorption. The Earth's surface, after absorbing part of this radiation, warms up and re-emits energy in the form of long-wave infrared radiation. A portion of this outgoing heat is trapped by gases such as carbon dioxide, methane, ozone, nitrous oxide, chlorofluorocarbons, and water vapor, causing a rise in atmospheric temperature. This heat trapping process is called the greenhouse effect. Without naturally occurring greenhouse gases, Earth would be very cold and unable to sustain life, as no heat would be retained. However, huge emissions, caused due to human activity, intensify the greenhouse effect, leading to abnormal global warming and adverse consequences. Greenhouse effect causes. The greenhouse effect is caused due to the accumulation of gases like carbon dioxide, CO2, methane, nitrous oxide, and water vapor in the atmosphere. These gases come together to form a blanket layer in the sky that blocks the way for the solar heat to escape in space. This trapping of solar heat leads to warming of the planet. Human-induced activities like burning fossil fuels like coal, oil, natural gas, and practices like deforestation, rapid urbanization, and energy-intensive industrial processes have contributed to the greenhouse effect. While natural phenomena like volcanic activity and variations in solar radiation contribute, anthropogenic factors remaining the dominant force behind the greenhouse effect. Greenhouse gases. Greenhouse gases are gases present in the atmosphere that absorb and hold infrared radiation emitted from the surface of Earth, creating a heating effect. These include both naturally occurring and human-made gases such as water vapor, carbon dioxide, methane, nitrous oxide, and fluorinated gases. Water vapor. Water vapor is the most abundant greenhouse gas present in the atmosphere that reflects back the heat to the surface of Earth, amplifying the heat. Water vapor's concentration is determined by temperature because warmer air holds more moisture and intensifies global warming. Carbon dioxide. Carbon dioxide is a greenhouse gas that is transparent for incoming solar radiation but absorbs the outgoing terrestrial infrared radiation. Some of this absorbed energy is re-radiated back towards the Earth and raises surface temperature. As carbon dioxide is denser than air, its concentration is greater near the surface of Earth, and its high presence is due to fossil fuel combustion, deforestation, and industrial activities, making it a significant contributor to global warming today. Methane, CH4. Methane is the second most important greenhouse gas after carbon dioxide, but has a greater heat-trapping capacity per molecule. It is produced naturally by decomposing organic matter and anthropogenically through livestock, rice cultivation, and landfills. Sources of methane include decomposition of animal waste and plant material, livestock rearing, where methane is released during digestion, paddy fields, which become oxygen deprived and generate methane through anaerobic decomposition, wetlands, permafrost melting, and decaying vegetation. Industrial activities like coal mining, oil drilling, and gas pipeline leaks. Historically, methane was formed when ancient plant material partially decomposed and was buried underground, later transforming under geological pressure. Its emission today is closely tied to agriculture, fossil fuel extraction, and climate-induced thawing of permafrost regions. Nitrous oxide, N2O. Nitrous oxide is a greenhouse gas that has a global warming potential about 300 times that of carbon dioxide over a 100-year span. It is primarily linked to agriculture and soil management. Sources of N2O include excessive use of nitrogen-based fertilizers, leading to denitrification by soil bacteria, animal manure management and sewage treatment, combustion of fossil fuels and certain industrial processes like nitric acid production, Natural emissions from soil bacteria and thunderstorms. Recent research shows atmospheric N2O levels have been rising steadily at around 0.25% per year. Though small compared to CO2, its impact on global warming is disproportionately large. Control measures, efficient fertilizer use, adoption of cleaner energy, catalytic converters in vehicles, and sustainable industrial practices can reduce nitrous oxide emissions. Fluorinated gases. Fluorinated gases are synthetic, industrially produced gases that have very high global warming potential and long atmospheric lifetimes. They are far more harmful than CO2, even in small quantities. Types include hydrofluorocarbons, HFCs used as substitutes for CFCs in refrigeration and air conditioning. Perfluorocarbons, PFCs byproducts of aluminium smelting and semiconductor production. Sulfur hexafluoride, SF6 used in the electronics industry and as a tracer gas. Nitrogen trifluoride, NF3 emitted during production of solar panels and flat displays, with a global warming potential 17,200 times greater than CO2. Black carbon. Black carbon, though not a gas but a particulate matter, plays a big role in atmospheric warming. Produced from incomplete combustion of fossil fuels and biomass, it strongly absorbs sunlight and warms the atmosphere. When deposited on snow and ice, it reduces their reflectivity, albedo, causing accelerated melting of glaciers and polar ice caps. Although short-lived, stays in the atmosphere for weeks, its impact is severe but also quickly reversible if emissions are reduced. Sources of black carbon include diesel engines, cook stoves, open biomass burning, industrial emissions, and wildfires. The black carbon impacts regional disruption of rainfall, glacial melting, and significant warming of the lower atmosphere. Brown carbon. Brown carbon has complex organic aerosols that appear yellowish or brownish in the atmosphere. These release from biomass burning, fossil fuel combustion, agricultural residue burning, and industrial emissions. They absorb solar radiation at ultraviolet and visible wavelengths, contributing to atmospheric heating, while simultaneously scattering some light, creating mixed effects on climate. Greenhouse gases effects. The excessive presence of greenhouse gases is causing large-scale environmental and socio-economic challenges. Rising sea levels, increase in ice melt leads to coastal flooding and submergence of islands. Extreme weather, hurricanes, floods, droughts, and heat waves have become more frequent and intense. Ocean acidification, CO2 dissolves in seawater, lowering pH and endangering coral reefs and marine ecosystems. Biodiversity loss, climate change is causing mass extinctions and disrupting ecosystems. Agricultural challenges, crop failures, lower yields, and food insecurity are intensifying. Health impacts, spread of vector-borne diseases, respiratory illnesses, and heat-related disorders are on the rise. Global efforts to mitigate GHG emissions. International and national initiatives are introduced to counter the threats posed by greenhouse gases. These global efforts include the Paris Agreement, a landmark treaty aimed at limiting global warming to well below 2 degrees Celsius, with efforts to cap it at 1.5 degrees Celsius. Renewable energy, transition to solar, wind, hydro, and geothermal sources to cut fossil fuel dependence. Carbon pricing, mechanisms like emissions trading and carbon taxes to incentivize low-carbon technologies. Energy efficiency, adoption of sustainable practices across industries and households. Carbon capture projects, investment in technologies to remove or store carbon emissions. Greenhouse effect and global warming. The greenhouse effect is important for sustaining life on Earth. However, human-induced intensification has resulted in global warming, which refers to the long-term rise in Earth's average temperatures. This warming drives climate change, ice melt, extreme weather, and sea level rise. The Greenhouse Gas Protocol, GHG Protocol. The GHG Protocol, developed by the World Resources Institute, WRI, and the World Business Council for Sustainable Development, WBCSD, provides a standardized framework to measure and manage emissions. It classifies emissions into 3 scopes. Scope 1, direct emissions from sources owned or controlled by an organization. Scope 2, indirect emissions from purchased energy like electricity and heating. Scope 3, other indirect emissions across the value chain, such as transport, waste, and product use.